Today we're going to do something a little different. We're going to crack open this beast of a technical manual. It's like 900 pages long. And inside, we're going to find the secret language that helps build some of the most complex, most incredible machines on Earth. Okay, so let's just jump right in with a huge, huge challenge. Imagine you have to build a modern airplane. I mean, think about it. Millions of parts, thousands of suppliers, and there is absolutely zero room for error. Where do you even start? You think it's all about, nuts and bolts, right? Assembling the pieces. But the real challenge, the truly mind-boggling task, is managing millions of interconnected rules and specs. We're talking about things like, hey, the landing gear, it has to deploy in under 6 seconds. Or this specific sensor must be linked to this specific warning light. These things, they're called requirements. And every single one, down to the last detail, has to be tracked, tested, and proven. And that right there brings us to the heart of our story today, what's called the million component problem. We're talking about a scale of engineering that creates a data management challenge that is, well, it's just off the charts. So to even begin to solve this, industries, aerospace, automotive, even medical devices, they all rely on this super critical discipline called requirements management. It's basically the art and science of making absolutely sure that everything you plan to build is actually what you ended up building, and that it works exactly the way it's supposed to. So how in the world do you manage a database with millions of these rules? A database where changing just one of them could have a ripple effect on 1,000 others. I can tell you one thing, you're not using a spreadsheet for this. No way. You need a specialized, heavy-duty tool. And for a lot of the world's most critical projects, that tool is IBM Rational DOORS. It was literally built from the ground up for this exact purpose, helping teams capture, track, and manage all those user requirements we've been talking about. But here's the kicker. Every project is unique, right? Building a fighter jet isn't the same as building a satellite, and that's totally different from building a self-driving car. So a one-size-fits-all software tool, it might get you, say, 90% of the way there. But in these industries, 90% is a failing grade. It's just not good enough. And this is where the real secret of DOORS is hidden. It's buried deep inside this huge reference manual. It's kind of like a hidden superpower that lets engineers take the tool and customize it to fit their exact unique needs. It's called DXL. That stands for DOORS Extension Language. You can think of it as a secret built-in programming language. It lets you tell the software how you want it to work, instead of just, being stuck with how it comes out of the box. Okay. Here's probably the best way to wrap your head around this. Imagine DOORS is like one of those giant pre-packaged Lego castle kits. It's cool, but it's set. DXL? DXL gives you the power to create your own custom Lego bricks. You need a special kind of window, or maybe a hidden passage, a taller turret. With DXL, you can literally build it yourself. And this chart, it just lays it all out perfectly. With the standard software, you're kind of stuck. You've got manual processes, a set way of doing things. But once you bring in DXL, everything changes. You can create these perfectly precise automated workflows that can even talk to other systems. This saves thousands of hours and, more importantly, helps prevent those critical, show-stopping mistakes. All right, so this all sounds pretty amazing in theory, right? But what does it actually look like in the real world? What kind of custom tools are engineers building with this language? Well, it all starts right here, in this simple-looking little pop-up. It's called the DXL Interaction Window. This is the command center. This is where an engineer can type or load a script to basically bend the software to their will. I know, it might not look like much, but trust me, this is the control panel for managing immense, incredible complexity. So what can you build with this? Oh man, just about anything. You could write a script that automatically spits out a 500-page safety compliance report. Or you could create custom pop-up windows to walk users through a really complicated task. You could even set up triggers so that when one tiny requirement changes, an email is automatically fired off to the right engineer. The possibilities, they're pretty much endless. And here's what's so crucial. These powerful scripts aren't just one-and-done things. They get saved into shared libraries. So a single engineer can write one brilliant automation script, and then boom, suddenly an entire team of 500 people has a brand new powerful tool right at their fingertips. That's a game changer. Okay, so you might be thinking, why have we spent all this time digging into some super niche scripting language from a dusty old technical manual? Right? Why does any of this matter outside of a few very specific engineering labs? Well, it matters because this ability to have deep, customizable control, is the hidden engine that makes our modern world possible. It's the code behind the code that makes sure a pacemaker is reliable, or that a rocket's guidance system is absolutely flawless. When you get right down to it, languages like DXL are a bridge. They're the tools that let our human minds successfully manage systems that are so vast, so interconnected, that it's physically impossible for any one person to hold it all in their head at once. They allow us to tame complexity. And that leaves us with one final thought to chew on. We've uncovered one secret language today, right? But it kind of makes you wonder, what other invisible scripts and custom-built tools are humming along in the background, quietly powering the cars you drive, the phone in your hand, and pretty much the entire technological world that's all around us?